All right, today we're going to talk about procedural decomposition. My goal is for you, at the end of this video, you will know what procedural decomposition is and you'll be able to use it to solve a problem by breaking it down into a series of smaller and, most importantly, easier problems. We will declare and call static methods to eliminate redundancies in your programs, and we'll examine the control flow of a program, which uses static methods. And then hopefully after you do all these things, you'll be able to explain procedural decomposition to someone such as your grandmother, or worse yet, my dad. If you can do that, you totally know what procedural decomposition is. All right, so we talked about algorithms once upon a time, not too long ago. And if you think about it, it's just a step-by-step instructions on how to do something. Recipes are an excellent example of an algorithm. Now note here that if I'm making cookies, I can just put a long series of instructions. And if I make a double batch of cookies, well then I would have to change all the instructions there. And it's kind of hard to read. So we're going to do something called procedural decomposition to make our algorithm look better. And it's easier to write as well as to read. Oh my gosh, what is this? I have no idea what this is. Oh my goodness.
You can.
It's Lord Farquaad.
I'm the gingerbread man! You monster! I'm
my.
not the monster here. You are. You and the rest of that fairy tale trash poisoning my perfect
What do
world.
you do with cookies?
Now tell me, where are the others?
You eat them. All right, I kind of ruined that. So what we're going to do is we're going to take this recipe, which is making a batch of cookies. And what we had before was a long, long list. And what we're going to do here is we're going to break it up in just 3 simple steps. Making cookies, you're just going to make the batter. Then you're going to bake the cookies, and then you're going to frost the cookies. That's awesome. It's only 3 steps, that's it. But you need to know how to make the batter. So to make the batter, you're going to do these things, right? And then to bake the cookies, you do these things. And then to frost the cookies, you do yet another set of steps. And in each one of these, we try to make the steps easy and simple to follow. So what we've done is we've taken a longer recipe, an algorithm, and we broke it down into 3 smaller steps. Making the batter, bake the cookies, frost the cookies. And then we write small algorithms or methods on how to solve those smaller and simpler problems. So decomposition, I always think of decomposition, I think of dead bodies. It's like, Walking Dead kind of a thing, because they decompose. And when you hit a dead body, what it does? It breaks up into smaller parts, and each one of those is gross. But I mean, simple and easy. Anyway, all right, so let's take an example here. We're not at the example yet. Here we are. We're talking about decomposition as a separation of a problem into discernible parts. That means each one is its own making, right? It's like I said back and before, we mixed the batter, right? I didn't say mix part of the batter and then, well, let's go back. I don't say make part of the batter and then bake part of the cookies as one method. Like they're very distinguished from one another, right? They make sense separately. So that's what the discernible parts is. They make really good sense separately. And each one has to be simpler. And then what a great design here is, in your decomposition, is you want to make sure your code does not repeat itself. Now, when you do decomposition, the awesome thing is it gives you tools that helps you make sure the code does not repeat itself. Oh yeah, the code does not repeat itself. And when it doesn't repeat yourself, we call it dry, D-R-Y. Don't repeat yourself. What? Don't repeat yourself. What? I won't say it again. Okay, so what I want you to do is I want you to pause this video and I want you to think about how you would write code to print out these 3 shapes. Okay, pause. All right, so hopefully you've taken a little bit of time to actually write down some things. But before I give you a possible solution, let's talk a little bit about flow of control, or tracing. Tracing is the act of basically executing computer statements in your head. So if I were to trace the flow of control of this program, then the first thing was I would draw this box, which comes down to here, down to this method, public static void method. And then I print these lines, and then I come back up, and then I print an empty line, and then I draw another box, which comes down here, and I draw another box. So this is the flow of control. Draw a box, print a line, draw a box. This is also decomposing a larger problem, which is to draw two boxes with a space in between. But we can also know that some methods can call other methods. So here I have a static method named bar that calls foo. It comes down here. Oh wait, we're going to start in main. Does it make a difference that main is at the bottom? No, it doesn't. Anywhere that main is, that's where you're going to start. So even though it's at the bottom of the file here, in the example, I would start down here. So I'm going to call foo. Comes up here. No, it calls here and does print line foo. Then it comes back. Then it calls bar. So after it goes up to bar, it calls foo, comes into foo, calls foo. Then where do we go? I'm at the end of my method. I go back up to the caller. So I go back up to here and I print bar. Then I go into foo again. So I can have a method call a method twice, the same method. I go into foo, and after I print foo, I'm done. Where do I go? I go back to bar, and there's nothing left here. So then I go to the caller of bar, and the caller of bar was main. So I go back down there. So what I'm going to do is, using this, I'm going to show you my solution, and it's just a solution for drawing those shapes. So let's pull this up. And what I did was I drew shape 1, I drew an empty line, then I drew shape 2, I did another empty line, and then I drew shape 3. Now shape 1, and let's go back and look at what shape 1 looks like. Shape 1 is this line with a V. So when I did shape 1, I drew my line, and then I drew a V. So I broke that problem down yet again. This is continued decomposition of the problem. This one here looks like the V and then an upside down V. So in my shape 2, I drew a V and an upside down V. And in shape 3, it basically looks like an upside down V and then a V. So in my shape 3, I did an upside down V and a V. It's very similar to the ones before. And so then in drawing my V, all I have to do is draw them out. And note that when I do a whack, I have to have double characters in there. So when I run that method, oh, that's not it. Let me run this method. That's for a different problem. When I run the method, I get my shapes. Okay? So that was one way to decompose it. There's lots of ways to decompose this problem. But here I have a method calling another method, and all I've done is I've identified that one simple component of every single one of these shapes is the V shape, and then plus this line. All right, I hope you understand. Let's see if we go, let's go back to here and see if we completed everything. So we did procedural decomposition. Oh, declare, I forgot that word. Declare and call static methods. So when we declare, what I've done is this right here is the declaration of a method. So here I declared a method called drawV. And here is where I call the method drawV. I declare it, I implement it, I call it. Okay? That's the vernacular we use when we talk about code.